Got the machine starting up. It does take its time. I do not know how this loads. Like I said, this is a fresh setup, fresh hookup. We're waiting on this for a minute. Glad to finally have it. Very excited, very excited. This does have the this is the rotary module of sorts. It is a mill. Sorry, mill. If they were to ever come out with the lathe, that would be fantastic. Not too sure how they would do that, but that would be awesome. So here we go. Safety instructions. Warning about the 1600 milliwatt laser. That's all I currently have. We'll be getting an upgraded one here before too long. Just been going through some family stuff. I know the channel has been significantly suffering. All I've been doing is posting flying videos, but that's been my relaxation for the time being. We're going to go ahead and acknowledge that we understand the safety instructions. Manual calibration and focal length. Okay, this guide will walk you through calibrating focal length to produce the best results. Step: input material dimensions. 2. Fix material. 3. Confirm height of material's top surface. 4. Machine engraves a few lines. 5. Choose best engraved line, the thinnest, and confirm focal length. So get started. So it looks like this one's going to be a test piece. Might be able to sand out, might be able to burn something over it later, I don't know, but we're just going to go ahead and get started from the ground up. Now it says material settings. Length is 75 and diameter is 40. We're going to double check this real quick. We do have an additional piece here that we're going to check. Make sure that this is correct. Fresh out of the box. Turn on our calipers here. Everything's at 0. Looks like we're running just under 41, so 40.8. By just under 75. So 75 will be fine. The diameter will also be fine, but it's not exactly correct. Alright, so we did the homing on this, and like I was saying, it did not come down center for the diameter of the workpiece. It's slightly off to the right. So we're going to get back to the calibration on that. I do just want to show this in case we have any errors with this later. This may be an indicator as to why. But we're going to get back to the measuring the height and the calibration on this. Okay, back to the screen here. So we're going to go for our Z offset. And I'm going to do this by eye, and then I'm going to show you where I'm at when I'm done. So I'm going to bring this down 1 millimeter. I'm going to step it up to 5. There is quite a distance over there. So I'm going to come down 1, 2. I think that's about close enough for that. Carefully lower the module to the material's top surface and tap next. So I want it all the way down on it, touching. I'm gonna go a paper width higher than it, just in case. It's not gonna be all the way down, but close enough. So. Got a few more to go, but I'm going to reorient this camera, set it up, and show you guys right where I'm at. Alright, so as you can see, I am right down on this. There's probably a 1/64 of an inch in there. I know we're using metric, but It's hard to go back and forth, do a lot of different jobs. So I'm bringing this down a couple more 0.1s. Alright, still barely see underneath of it. It's not going to make a difference that much, but that's where I'm going to leave it at. Now we're going to get... This is where we're going to leave it at. So we're going to check this out and get back to the main screen. Alright, back to the main screen here. Got everything going. Now we're going to hit next for the height of the B axis is completed. It says put on laser safety goggles. You probably should. I know that there's not going to be enough of a light discharge around the diameter of that to affect anything, so contrary to what this says, I'm going to be not safe. But we're going to go ahead and hit next, have the laser turn on. Set work origin. Use X, Y, and B offset to set the work origin. Always tap run boundary to check the work area. This may help us correct the X on it. So as I was saying, it was the X was slightly off to the right, and as you can see right here, where the top of the radius is here, it is just slightly off. Not a lot, but you know, enough to make a difference. So we're going to bring it back a little bit. I'm not sure exactly how much yet, but 5 was too much. So looks about equal. I think maybe we'll go back see what happens with 1, 2. And we'll go down to the 0.1s. I wish it would let me bring the Z. For now, we're going to hit next. No, we're going to hit set work boundary, or set work origin, rather. Let's see, run boundary. Let's see what happens here real quick. Alright, we got a warning that pops up here real quick. I want to show you guys. Alright, as you can see, it says, warning, if the work origin is improperly set, the laser module might crash into the material when you perform run boundary. Got it. So, I'm assuming that it saved the Z axis on, and all we were doing was setting the B and X, but we're going to see, and I'm going to back this up as soon as before we hit got it, that way we can see if there's any error or anything that happens in the process of doing this. Alright, we moved out. The only thing that's changed since the last clip on this video is the position of the camera. I have not touched anything, moved anything, changed anything. Simply moved the camera. We still have the same screen up over here. We're going to go ahead and hit got it. And that did not work because our work boundary is way too high. I don't know why I put it up in the air like that. Oh, look at that. We can change the rotation. So you swipe this side to side. You can change the orientation of the piece. That's nice. We're going to go back. We'll go back to the Z. We're going to bring this down. This time we're going to save it. Bring it down one more. Drop down to 1 millimeter. 0.1 millimeter. I'm happy with that. Do this again. Next. 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 I am fine with where that was at. We were fine with where this is at. This should have all saved. We're going to hit next again. Let's hit start and see what happens. Okay, we are experiencing significant error here. That is super bright. I do not know why that didn't save. It is not making any lines whatsoever. So I literally have nothing to show you guys up there because there is nothing to show, nothing burnt. The laser was too far off. I don't know why it went that high. So we seem to have came to an error. We're back to the processing. It says do not move the material during the process. It says processing. The process is not going on. I'll figure this out for a second. Alright, so we had to restart this. I sat there and said process, process, process. Did absolutely nothing. So we had to restart it. We're going to boot this back up and see exactly what's going to happen this time around. See what we can do to fix whatever mistake that we just priorly made. Safety instructions, we understand. Get started. Everything's correct here. Going home. We are home. We're going to hit next. And it stopped. Z offset, starting back over. 5mm increments. 1mm increment. 0.1mm increment. Probably good there. I think I moved that a total of 14.4, 14.9, somewhere in there. B offset. Let's just mess with this for a second. We'll take a quick pause and reset the camera. Alright, before we get started, I'm just going to take and put a little dot down at the bottom of this to see it actually move. Move this in just a little. Yeah, there we go. Alright, so I'm going to try to rotate this, see how it works. These are 5-degree increments. Back home. Alright, don't know what else we can do. We are literally right on the tip of this. feel like there should be a save right here. Next, put the goggles on. Use X, Y, and B offsets to set the work origin. End of the marker. Goes flying way back up in the air again. Z is locked out. Did notice when this started the last time, it did come flying way off the end of it here, and then it worked its way back. So I think we're going to move Y in at least 10 millimeters. Now if I hit set on this, it's going to lock it in the air again. What else we have here? Set Y, Z. Z origin is locked out. Let's try just setting these three. Let's set the X, the Y, and the B. We're going to try next again. This time I am going to grab my safety goggles. That was extremely bright. Also going to move my kid in the other room real quick. Alright, manual focus. Here we go. We're going to give this a test and see if we can get back down to the original height where we had the Z set at. No. Still not working. This is a little irritating to say the least. It says it's complete. Slide to choose the best engraved line. I'm just going to hit complete. Maybe we can manually operate this later. Alright, it says congratulations, awesome. You've completed the initial setup. Now you can prepare a G-code file using Snapmaker. Alright, let's see. That literally did nothing. Let's turn around and go over to our, let's go to Luban, and we're going to run the Tiger code on this, and we're going to put it in manually with the USB stick. Alright, we do have the USB drive loaded over here with the file on it. It's Laser Test Fourth is the name of the file by default from Snapmaker. We're going to go ahead and go to Start. We're going to come down here to the USB. Laser Test Fourth is right there. So it says that everything is ready. Laser is at 100% power. Work speed is at 100% power. Estimated time 33 minutes and 11 seconds. Just settings, that's just the laser power and the work speed. So we're going to exit that. We're going to say ready. The length we said was 70 millimeters, and this was 40, I believe. Doesn't hurt to double check. Yep, a little over 40. Just over 75. Probably counting it down here somewhere. I don't know exactly where they came up with 70 from. Must be the distance from the tip of the chuck to the end of the material. So we're going to go ahead and hit next. Secure the material. It has been secured. Next. I'm going to say go to work origin real quick and see if it's going to drop it back down to the site. Nothing is happening. Run boundary. Warning, if the work origin isn't properly set, the laser module might crash into the material when you perform the run boundary. I got it. Alright. So we're still super high in the air for some odd reason. And Z is still not letting us do anything. By default, I'm just going to go ahead and run this for a quick second. Actually, no, I'm not. I know what's going to happen. This thing's going to print in the air and it's not going to friggin' work out right. So, how do we correct this? Let's go back. You know what, I'm going to go all the way back to the beginning. We're going to go to Control, Z offset. And we're going to change this right now. Can I do one more? Yep. So that was 10 times that I hit that. That was at least 50 millimeters that it was off. That way, I'm going to bring this down. 1, 2, whoop. 1, 51, 0.1, 0.2, 0.3, 0.4, 0.5, 51.5 millimeters it was off in the air. Don't know why that's a thing, but we're going to say that this is set work origin area right here. Actually, no, it looks a little off. We're going to take our Y by 1 millimeter, and I want to have this go to the right. So we're going to hit left. Oop. Bring it back about halfway. Looks good to me. We're going to say set work origin. Set work origin. Alright. Now we're going to go to home. I see why they have you put the glasses on. You will blind yourself if you're not doing this right. Every time I've came across something with this, there's been an issue. That's why I literally always record this every single time I try to do something. This time is no different. So we're all the way home. I'm going to go to work origin. Because for some odd reason this didn't set the first time around. Boom. Perfectly. Alright, so now to get this started, I'm going to do a time lapse on this just so long as this will start up. I'm going to go to Files. I'm going to go to our USB drive. We're going to go to our laser test fourth. We're going to go to Ready. 70, 40, select, hit next. This is correct. Now this time our glasses really don't have to be on because we're not printing, 51.5 millimeters off the surface of it. We're going to get right down there and we're going to do the job the right way. First things first, before we get started, we're going to go to Work Origin to make sure that this stayed. Work Origin did not stay. Run boundary. Well, let's go to Work Origin. I don't understand why this is doing this. See what happens if we hit start. This is not what we're looking for. So you had to go back through and redo a calibration on this. And this time, for some odd reason, the laser did go all the way down. I didn't really change anything. I just went back to the calibration. I went from the Z to the XYB. So going to just move the camera here a little bit lightly. Get an idea of what's going on so you guys can see. Also, I'm going to use a flashlight over here. So as you can see here, it did finally engrave, and this is with the auto mode. I'm going to say, quite honestly, we're going to go with the middle one. So just like we selected before, for some odd reason this time it acted differently. I did go through, try to recalibrate it. Like I said, like I showed, we're going to go to complete. So that's all said, done with. And it did actually burn pretty high off. About where it's at right now is the height that it did do the laser engraving at. So that being said, we're going to try to go ahead and move forward with this. Now, with this being preset, no matter if you shut it off or whatever, it should always maintain the same settings until you go back through and redo everything. But for right now, we're going to go to control. We're going to go home. Just testing this out to make sure that it'll work fine. Did notice that the chuck is directly up with the back line here, and then that this is a little off-centered, as you'll see here real quick. Don't exactly perfectly add up from here to here, but anyway, this is the trial and error run. So we have that. We're going to go to B origin on the side here. And I'm going to turn around. I'm going to try to use this same piece and use it for the first print of the lion laser. B origin. Oops. We have to go back. Here we go, B. So 5-degree increments, we're going to see what is 180 divided by 5. 36, alright, something like that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Looks about right. So we're going to go back here. Totally screwed that up. See what happens. Alright, so carefully lower the laser, blah 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 blah. Try this again. Whoops. Always do that. There we go. Next. Next. Go. We should maybe go this way just a hair. Now that looks better. It's right over the top. Next. Let's go to run boundary, see what happens. Whoa, we're way out. Let's try up there. Get back about an inch. Next. That looks good. And we went back to the focus thing again. Not too sure why. But here we go. This is doing the manual focus. Definitely have your lenses, your glasses, your 10 shield on, whatever. Pretty bright light, very spicy. Alright, all said and done. I'm going to do one last look at this. One last look at this here real quick. There we go. One last look at this here real quick. See how it's kind of darker in the back, lighter in the front. I definitely like the center line, so I'm going to go with that. We're going to go ahead and accept this. at 0. So, file. We're just going to go ahead and run it right over the top of this and see how this works. This is just a check to see how it's going. Ready. Length 70. Diameter is 40. Materials set. Glasses on. For some odd reason, this will not let us go any lower than this, and I have a very good idea as to why. Pretty sure this is a safety setting pre-built in by Snapmaker to avoid letting the laser run into the chucks on the rotary tool. That's very smart. That's very smart on their call. I'm glad they did that. I'm sure they probably busted at least 2 or 3 of these in their own little experiments on this. But we're going to run this right over the line that we had it at. I'm going to do this in a time-lapse mode, so get that set up and we'll take a look at this when it's done. Alright, so part 1 of the project is done. Alright, we went through, we calibrated, we figured out what we had to do, got everything set up, brought everything into focus, we figured out why there's an offset between the tool, the laser, and the workpiece. That is because Snapmaker has installed a safety precautionary feature to avoid having the laser running into the chucks. Again, hats off to them. It's a good job. Protect your own tooling. But for right now, we are going to get this unlocked. Take a look at it. Now, this is just cardboard, so there's a little bit of a ripple on it. I did clamp it down rather hard. Here's our original test piece. Little light, pretty precise, but it fades out, comes back in a little wider right there. Then we did the second one, and here is the lion, the finished product. I did it right over the second calibration piece, but I'm telling you, the quality of that is spot on, phenomenal. That is pretty nice right there. Cap right here. Go ahead and put this back on. Now that'd be a nice little holder, nice little piece for having something sent in, packaging, for tooling in the shop. You know, something, whatever it is that you feel like you might have a use for something like this for. But for right now, this is the initial setup for this part 1. We're going to get into some more of this later. But for right now, this is all we have. Thank you for watching.